Good morning and good afternoon. Thank you for joining us today. My name is Becky with Lake County Market Research, and I'm here to introduce our analyst team, of which we'll go through the series of 3 presentations and take questions at the end. Our analyst team will be online for the real Q&A, but we'll go ahead and get started now. With that, I'll introduce Roy Rubenstein. Roy?
Thank you, Becky. So, hello everyone, and let me take this opportunity to first thank Layer123 Europe for allowing us to take part, but also to thank you for taking time to hear what we're presenting. And this is the result of a study we did looking at the whole issue of network transformation. So I'll start this presentation by going into a bit of detail as to sort of our findings and what we're highlighting in terms of this whole topic of network transformation. But an important part of what's happening now is 5G. And so I will hand over to my colleague, Stefan Terrell, Chief Analyst at Light Counting, who are going to detail as to why 5G is such an important catalyst for network transformation. And then when he completes, he will hand over to Vladimir Kozlov, the CEO and founder of Light Counting. And he will address the whole issue of how network transformation is affecting the supply chain or sort of the ecosystem. So let me start, please, with the first slide. So what we're showing here is sort of 3 choice quotes, which all introduce sort of different flavors of what is happening or associations with network transformation. So starting with the upper quote and going clockwise, this is how the CEO of AT&T introduced the last quarterly results and really a summary of 2020. And the quote speaks for itself in terms of the difficulties of the year for the telco world. But what we're really highlighting here is one aspect of the COVID story was just how much work the operators had to do in adapting their networks to sort of unprecedented demand. And it was almost a step function change in what was being asked of their networks. There was changes that would normally take a year that were happening in the space of a week. And one of the operators handled this almost flawlessly, or in terms of the end user, it was flawless. And a large part of that was to do with the network transformation work that had already done. And this is something AT&T, but others have been vocal about. The second point we're highlighting here is a quote from Don Clark, who sort of will be related to the next slide, in that he was one of the authors in the start of all of network transformation in the sense of the ETSI NFV white paper. But really what he's talking about here is innovation. And innovation is one of these sort of rumbling topics associated with telecom. And he's part of a group that's looking at this whole issue of how can telecoms better benefit, because their underlying argument is the very nature of the culture of telecoms is impeding the rate of innovation that's needed. And then the last quote, again going clockwise, is a nice quote by Amazon Web Services. And really the article this is taken from was all about sort of asking this particular cloud player what their intentions are in terms of partnering with telcos. That was the underlying theme of the article. But really what he was pointing out here is there's a good reason for the collaboration between the large cloud players, whether it's Google, Amazon, or Microsoft, and the telcos. And the reason for it is that there's this confluence of technologies and technological change, and it doesn't happen often, but when it does, it causes sort of ruptions in the industry. And what we're seeing here, there's a good reason for this collaboration because it's needed for both parties. So next slide, please. So this comes back to the reference to Don Clark and the ETSI white paper, which can be seen as a starting point for all of this. And very briefly, if you still read that, or if you read that paper 8 years on, many of the aspirations and the goals and the motivations for why these 13 telcos wrote this white paper pointing out that there needed to be a fundamental change in how networks are architected. The reason they did this and their aspirations, if you read them now, many of the things are still relevant. So it was a prescient document, and it's still relevant to what's happening now. But the point we're making is, in a way, how much change has happened in these 8 years. So very, very briefly, the whole motivation for this was that they realized that they couldn't continue this way because platforms were customized and they had complete stacks, and it just took too long to do any changes. And there were opportunities that operators couldn't benefit from. So what did this lead to? It meant opening up these boxes and the whole issue of disaggregation so that SDN could be used as a centralized control. And once you started disaggregating, you had this methodology of sort of network function virtualization where things that previously were all encapsulated could be separated and implemented in software. So disaggregation is a key theme. It's ongoing. It's not, the story hasn't ended. But there's also other aspects of opening up the network in this way, which is the advent of both these virtual network functions and white boxes. So it means that there's more players that can play here and sort of greater vendor choice with all the consequences of that. There's also been the development of open source and open networking practices, which, again, looking back over the 8 years, this didn't really exist in telecoms 8 years ago. So a lot has happened, and organizations have come about and have now matured and have sort of hit their stride. Has the service benefits, this speedier, greater agility come about? Well, there's still issues with this, which perhaps we can touch on. But again, going back to COVID, that's an example there, perhaps not what the operators are really aspiring to, but it showed what could be done in very short timescales, which again, would not really have been possible 8 years ago. Last comment, as a result of this 8 years of work, are telcos more like internet content providers? Well, to a degree, yes, but there's big differences, and telcos have much more heterogeneous networks. It's not to say that data centers aren't complex in their own right, but they're also not. Every time you set up a data center, it's almost like a greenfield deployment. But here we're talking about introducing a whole new way of working and new technologies alongside a network that's taken years and decades to build. So the telcos are dealing with a much greater problem, even if their underlying aspirations are to be more like the internet content providers. So next slide, please. So this is a bit more detail, but the takeaway from this slide is that, like historians, we're calling the end of a certain period and the start of the next period. So the first period, or phase one, is really what has been done in the last 8 years. So the first part was the different elements to get this in place, but then the sort of rolling up of the sleeves and the work that has been done. So whether it's the introduction of virtual network functions, this open networking taking hold, the whole orchestration and automation associated with these new ways of implementing network functions, very different to what was done before. And really why we're calling the end of this period is because certain targets have been met, certain initial goals have been met in the last year. So whether it's AT&T reaching its 75% virtualization goal, or the likes of Telefonica with its Unica program, suddenly talking about Unica Next and IP Fusion or iFusion Plus, the SDN part of that program. In other words, they've met initial targets and are moving on to the next stage. But looking at this new era, so whether you call it network transformation phase 2 or network cloudification, what is happening now is again different. And perhaps one more way of explaining it, and we'll go into a little bit of detail in the next slide, is what's being tackled now is different to what has been tackled before. So the focus is moving to the edge. And in a way, it's the completion of this network transformation in the sense that what's been done up till now has very much been core functionality and to a degree, central offices, but the focus is now shifting to the left, to the edge, and a lot of that is to do with 5G and the consequences of 5G. So let me go to the next slide and we'll explain this a little bit more. So here's a bit of detail of this phase 2 that we're talking about. So we've touched on it, this collaboration between the internet content providers and the telcos at the edge. And an example of this, but it's not the only program, is the wavelength zones. So the 4 operators that are working with Amazon on this, they're all now pretty much live with this. So they've started this service. And in a nutshell, it's sort of placement of Amazon equipment at the edge of the operator's 5G network, and basically providing a development environment that all the developers are familiar with, but which can now start implementing 5G multi-access edge computing services. And once these services go live, both parties start getting new revenue. Another aspect of phase 2, which is this move to cloud native, and that's partly baked into 5G, but it's also going to be required. Plus it's an indication of the evolution of network transformation, where cloud native is becoming the way virtual or network functions will be implemented in software. Another aspect that we're pointing out is Open RAN. So Open RAN is a huge issue in its own right. And there's all sorts of important aspects to this. There's a political aspect to it. There's the backing of the operators. But what we're really pointing out here is everything associated with network transformation is encapsulated in Open RAN. So you can look at Open RAN as part of what's going on in the network, but in its own right, it needs all the ingredients of network transformation. So disaggregation, the use of software, you're bringing in a load of vendors to implement what was previously perhaps done by one. And there's degrees of disaggregation, and the network, the software practices to bring this all together and how it will work and how it will be orchestrated. These are huge challenges, but it's all the elements of network transformation that was been done up till now, but using it for a specific use case. And then the last point is, if you step back further and say, well, what is all this about, or where is this leading to? What is the aspiration here, and what will it enable? And here we're pointing out sort of there's 2 countries or 4 operators. There's China and Japan, and they do have a grand vision of what they're doing, both with 5G, the sort of combination of telecom and cloud, and how this will enable sort of a greater program, which is to do with both the industrial performance and competitiveness, but also serving society and societal goals. So whether it's smart cities or it's enabling verticals or environmental issues. And what we're showing on the right, again, very briefly, is a nice example of really what's involved here, so a bit of concrete. So the first aspect is just the merging of fixed and mobile networks. And to a degree, NTT has bought back or now completely owns NTT Docomo, so it's got control to be able to do this. And then on top of that, there's the software layer that both it and NSC will work on. So an operator with software capabilities, but working with a key partner, which it's invested in to help it in this initiative. It shows white boxes that will enable this network transformation. And then right at the top is all the verticals. And just one last comment, this is ambitious in terms of how they plan to use optical networking, but also they're already saying that they will need more than just 5G for this. So a hugely complex vision, a sort of decade vision, but also showing what network transformation could lead to. And the same with China with its use of 5G, the importance of 5G. So next slide, please. This is another representation of sort of phase 1 and phase 2. But really the takeaways from this slide is, in a way, the importance of 5G for the network transformation work that's going on now. So whether it's the core or the edge or Open RAN. And this other observation that there's almost legacy appearing within this network transformation work. So you're not only talking about physical platforms or PNFs, you're also talking about virtual network functions, now cloud native network functions. So it's showing the completion of all the areas of the network that's being addressed, but also the importance of 5G. Next slide, please. And this is sort of my final slide before I hand over to Stefan. So this is a partial list, but this is all challenging for all sorts of reasons. But let me just sort of point out a few things. So we touched on this with why Open RAN is so challenging, and that's just one part of network transformation. Orchestration and automation, this gets more complicated over time and will be needed if the potential of 5G, of all the elements of 5G, you will need more automation. And just orchestrating these various aspects of the network, these both different types of virtual network functions. But sort of my concluding remark in terms of challenges is pointing out the importance of how the operators are taking a bit more control of what's happening here. And this is a definite trend for the last 18 months or so, maybe 2 years. And what we're really saying is there was a time when telcos did everything, but that was a long time ago. And then the pendulum swung in the other direction and vendors did more and more. But with this new environment of network transformation, the operators have realized that they can't just leave it to the vendors. They have to be more definitive in what they want, because there's been issues in terms of how the network transformation has evolved. So there's different programs here mentioned. I'll just mention one, AccuNet, which is this idea of there was too many underlying infrastructure platforms to address different use cases, which meant that operators would get virtual network functions from vendors, but they would each have to tweak them to get them to work on their underlying infrastructure. So now there's more rigor here. And it means that there'll be a subset of predefined architectures that will be needed and used. And there'll be more testing of VNFs to make sure that they work for each of these use cases, so that this idea of you plug and play will be much more likely to work and just require a lot less effort, both by the operators and vendors doing this together. So this is an important development, but it's also an indication of the sort of maturity here. And again, perhaps with things like Open RAN, they will be more conscious of what could potentially go wrong, such that they won't have to do these iterative corrections as things evolve. So let me just stop there and see if there's any comments from my colleagues before I hand over to Stefan.
Yes, thank you, Roy. I do have a secret question for you. And just provide a bit of a background for the audience. Roy has been covering the industry for more than 2 decades and worked for the last 17 years, worked at Light Counting, looking at the network transformation, looking at the service provider issues for the most of his career. So Roy, let me ask you a question. Are you personally disappointed seeing how difficult this transformation is and how long it's all taking?
I'm not disappointed, and I'll put a sort of an opposite comment on it. I think sometimes what is lost is when you look at what has been achieved in the last 8 years, so it's 8+ years, and there's been a lot of negative commentary about NFV, and some of it with good reason in terms of the vision and how much is fulfilled. But if you step back and look what is being done, it has to be done, and it's so complicated, and there's sort of evolutions or transformations within transformations and within the transformation. So it's just hugely complicated. Plus, while all this is going on, networks have to run, and operators are struggling to make, to be profitable. So it's a huge, probably the most ambitious thing that they've done in decades. But they have to do this, but it's not unreasonable to expect it to take time. It would be wonderful. It would be wonderful for everyone if it was faster. When I say everyone, not just for the telcos, but I'm sure the cloud providers and these verticals, but it's just going to take time. So when I look at this, I'm more sort of the glass half full, which is the sort of scope and ambition of what the operators are trying to do. That's my take on it, Vlad.
I see. Thank you, Roy. And you know, since I interrupted you already, let me introduce our next speaker, Stefan Terral, who joined Light Counting about a year ago as a chief analyst. But Stefan had a very long and successful career in market research, covering wireless network for the last at least 15 years. When I first met Stefan, more than 20 years ago, he was actually covering optical networking at the time. So he's been really looking at the industry from many different angles. And I'll let you, Stefan, take over, and I'll move the slide for you.
Thank you, Vlad. But you know, at the end of the day, C equals, well, lambda equals CT, C over F. So, you know, counting wavelength or hertz, you know, that's pretty much the same thing. We are still in the same domain. And speaking about domain, here is the theory actually behind what we have today and what we'll have tomorrow. This work started at Bell Labs at the beginning of this century, and it is called the regions, the 5 operating regions, as functions of data rate versus users. So you have the number of users on the horizontal axis and the data rate on the vertical axis. And basically, you know, when you put when you pile up all the users under a cell, you end up eating up, consuming the bandwidth, depending on what you are doing. That means the throughput or the data rate. So today we are in region 1, meaning there is not that much difference between how we started the 4G journey back in 2010. Yes, the very first networks, actually one was launched in 2009, but it was really 2010, so 11 years ago, because in 3G was not a success. So it's really with 4G that we enjoyed and developed mobile broadband. Today with 5G, we're enhancing mobile broadband, so we are providing more choice, basically. So you'll have more throughput on your device. That's where we are. Now, there is a region we'll never get into. This is region 5. This is basically where Shannon, who also is from Bell Labs and came up with that signal processing theory back after the World War II, and showed, you know, the limit of how many bits per hertz you could squeeze. And R5 is basically, we won't go there. And I can tell you a lot of people, researchers all around the world are looking at moving to quantum communications, for example, but first we need the computers, right? Then you connect the computers, quantum computers, with quantum communications, but still in the quantum domain, you have to prove Shannon's theorems, one after the other. I think we are at half of them. So now, you know, what's left in there? Well, the next stage will be R3 and R4. Basically, you know, when you need low bit rate, so this is R3 pretty much with a lot of devices. So let's say smart meters, for example. So we want to connect these to the same network, 5G, same network as we are using us human beings for enhanced mobile broadband. Then on R4 is the other one. It's the high reliability and low latency. So that means the URLLC, like remote robotic surgery, for example. So these are the 2 domains that are coming because this is the promise of 5G with a flurry of use cases in order to help service providers monetize actually their infrastructure. And then there is the other one, R2, where basically you go very high in data rate. And, I mean, are we thinking about 1 terabyte, 1 terabit per second? I mean, this is exploration domain. Will it be 6G? Maybe. And that basically leads us to the next slide, where I'll be showing the different phases of evolution that led us to where we are today. And where we are today is basically LTE, because we still have long-term evolution. Yes, we are enhancing LTE, and if you actually are only on LTE, it's still in the 3G domain, 3.9, between 3.5 and 3.9 G domain. In order to move into the 4G domain, you need to at least add carrier aggregation, then higher order modulation, and you are what is named LTE Advanced, and that is 4G. So what's interesting with 5G is that you can see we're literally building up on existing 4G. And this is the first generation with no real new air interface. We are still using the OFDM-based MIMO. No change there. And even though there are plenty of new waveform candidates and new modulation schemes, there was a big battle at 3GPP to accelerate 5G rollouts. And they say, oh, no, let's stick with OFDM. Okay. But the new things, some of the new things are coming from the coding domain with LDPC to enable massive MIMO. And that's where we are. Still, a lot of research is going on, moving into 6G. And the definition is being sorted out. We have seen lots of 6G activity since last year. And there are 6G symposium. The European Union set a big 6G project. There are 6G projects everywhere. But some people say, well, look, it looks like we have promised a lot with 5G, and we are under-delivering already. Remember that in 4G, we were so disappointed with 3G that we under-promised and we over-delivered with 4G, actually. So now let's look at the next slide to see how all of this is pushing development in networking. So basically, you have on the left side of the slide the series of events or research innovation events ranked in chronological order that led to where we are today with 5G. And that is a new radio attached to an existing 4G network. This is the non-standalone mode, NSA. We are moving into the standalone mode. That means a G not B, a plain new 5G node that will no longer be attached to an existing E not B, which is the 4G base station. We have already seen, the migration. Very few, I think, a dozen SA networks right now. But that, if you have the access already set that way, then you need to do innovative things all the way to core networks. And that leads us to the edge. To start with, what do we do? At the edge, particularly when it comes to enable use cases that needs very low latency. So that may lead to the decoupling in the RAN domain. For example, you take the baseband unit, you split it into the central unit, which is the upper layers of the BBU, and the distributed unit that you put closer to the radio unit. But you still need a link in between, and that leads to the concept of front haul between RU and DU, mid haul between DU and CU, and then what we know as the backhaul. We see a lot of fiber coming in. Then that traffic needs to be aggregated. So we have cell site routers that are being disaggregated, meaning that the hardware is becoming a white box, and the software is becoming a network operating system, a NOS. So we see the start of deployments of disaggregated cell site gateways. After that DCSG, you have to go to an aggregation router. Some DCSGs actually have been configured already as disaggregated aggregation routers. Then we go to the core, and with core routers, AT&T, for example, upgraded its IP backbone with disaggregated core routers using disaggregated distributed chassis, because you can also disaggregate the hardware. And using NOS, in fact, you can also disaggregate the software, and depending on how many sub boxes in your big white boxes, you can put a NOS on top of each, because you have to run those boxes and run all the functions of the core routers. So AT&T prepared its IP backbone for 400 gig interfaces, and that paves the way to the next part of this presentation, led by Vlad, our CEO and founder.
All right, Stefan, thank you very much. So I'll start with looking at some of the numbers, and as the name of the company suggests, Light Counting has built its reputation on providing the industry with reliable data on the market and realistic forecasts. These charts are based on publicly available data on revenue and spending by top 15 service providers. We abbreviate them as CSPs, communication service providers, and comparing it with internet content providers or cloud companies. And this data is really frustrating if you are a service provider, because cloud companies demonstrated very steady and healthy growth in revenues over the last decade. And last year, that growth was accelerated because of increasing adoption of cloud services. In contrast, service providers' revenues were kind of stagnating and actually declined slightly in 2020. And yet service providers continue to spend a lot more on investing into the infrastructure, while cloud companies investing relatively little. So it's a dilemma, and I think this chart certainly emphasizes the need for service providers, on the one hand, to find new sources of revenues where 5G offers opportunities. On the other hand, maybe to reduce the spending on the networking infrastructure. And one approach for service providers would be to use strategies that cloud companies developed for designing white boxes for equipment, buying optical components directly from suppliers, and kind of evolve the supply chain supporting the telecommunications industry to kind of two different conditions. So, a future situation shown on the right would be something similar to what cloud companies are using today. So most of the equipment that they deploy is really built out of white boxes, and they reach directly to suppliers of optical transceivers to fill in those boxes with ports. So that was a key for very large cloud companies that buy millions of servers per year and tens of thousands, if not hundreds of thousands of switches. Some of them are deploying the same strategy for their optical transport solutions. And I think Amazon started deploying white boxes for DWDM transport, populating it with pluggable, actually not even pluggable, but board-mounted DWDM transponders made by Acacia, which is of course part of Cisco now. And that kind of takes me back to the current situation, which is shown on the left, that, majority of equipment that's going, particularly in the DWDM transport market, would be so-called black boxes. So these are proprietary designs that's made by companies like Huawei, Ciena, Nokia, and others. And these companies, are buying components, buying modules to complete those designs. However, the trend that we're seeing is towards more of vertical integration within those equipment providers. And I think Cisco's acquisition of Acacia is an example of that. But in addition to that, what we've seen is that Ciena, Huawei invested heavily into developing internal manufacturing capabilities, not only for modules, but even for components. A lot of this work started with coherent DSP technology, which is a very complex, very capital intensive type of process. So only few large companies can afford this type of development. But equipment suppliers are starting to make optical components, lasers, modulators, detectors, and more importantly, building it as integrated circuits, which could be also integrated or at least co-packaged with some of the electronics, including DSPs. So in part, it's driven by technology transitions that integrated optical solutions actually do provide for better performance. But a large part of it is driven by equipment suppliers kind of staying ahead of the industry changes and taking more of the possession of the supply chain, taking more of a control of the supply chain to remain relevant to the service providers and remain sort of a key suppliers to them for many more years to come. And of course, the proposed changes shown in the middle, there are many different routes. And in fact, the system the actual system is probably more complex than any diagram can represent. But if you look at the future situation, transition to the white boxes that Stefan mentioned, I agree with Stefan that we're certainly seeing it on the edge of the network. So if we look at the edge routers, if we look at customer premises equipment, a lot of it are white boxes, and it's filled in with modules provisioned directly by end users, service providers. So it certainly works for kind of a high volume, massive deployments on the edge of the networks. When we look at the core of the networks, the transitions are much slower. And despite very good solutions available, if you look at the optical transport, I think TIP did a fantastic job for the last 3 years, providing very competitive those pizza boxes type of solutions, kind of mimicking a lot of the designs developed for cloud companies, offering this to a larger community, and working closely with service providers to have them take this opportunity to transition to the kind of standardized white boxes that could be populated by optics standard optical solutions. However, we see very little movement, particularly from the large service providers jumping onto these solutions. I think TIP is disclosing a number of new customers, but many of them are kind of in distant regions of the world, not the largest companies, at least not yet. So the transition is certainly slower than I would expect. And, I think on my side, I would see the glass as half empty, at least in this part of the transformation. But, one of the reasons it's half empty, at least from my standpoint, is that leading equipment suppliers are staying ahead of this transition. So if you look at their latest products, many of them look actually very similar to what TIP is offering. And in some cases, they actually exceed specifications of the TIP designs by offering more functions specialized for service providers. And that adds another argument for service providers kind of maintaining the status quo and staying with the existing equipment manufacturers who know their networks, who've been designing not only hardware but software for their networks for many years, in some cases even running those networks. So it's certainly an easy strategy for service providers to stay with suppliers that they know. And it will be interesting to see how many of them will open up to solutions offered by TIP or other organizations developing white boxes. Another argument in favor of maintaining status quo in the optical transport market, if you look at profitability of suppliers of optical transport equipment, and we selected sort of a pure players there with just ADVA, Ciena, Infinera to calculate average profitability. The profitability is very, very modest. In fact, these are GAAP numbers. Non-GAAP numbers are slightly brighter than that. But, the profits of the optical transport companies are modest, and the competition between them is brutal. Even if Huawei is excluded from the North American market, there is enough competition between, Ciena, Infinera, ADVA, Nokia, a few smaller players, and Cisco, of course, is part of that competition. So it's a very competitive market. So I think the end users probably are right to be comfortable knowing that they're probably getting good deal on their purchases. If you look at the profitability of switch and router companies, again, we selected kind of a pure players, more or less pure players with Arista, Cisco, and Juniper, which are much more profitable businesses. So there is certainly less competition. There is more sort of kind of, if you will, captive type of environment where operators tend to stay with their suppliers for very long periods of time, and there are not that many suppliers to choose from, particularly on the core router designs. And I think that was one of the key motivation why AT&T, as Stefan mentioned, introduced the white box core router a couple of years ago. I guess it's 3 years ago by now. But more importantly, in the end of last year, they actually started deploying the core routers based on white box solutions. And I think that movement in turn forced Cisco to unveil their new strategy. They call it the Internet of the Future, when they are willing to provide their software, their silicon, their optics separately to the end users, basically in any combinations the end users are willing to purchase it. So in a way, I think that the AT&T work triggered some of the transformation in the suppliers, forcing them to kind of accept the new reality. But at the same time, it helps them to stay ahead of the changes. If they can lead the industry in the right direction, they have more chances of staying still relevant and maintaining their, well, in the case of Cisco, #1 market position in the core router market. So it's a living system. You look at the ecosystem, each category of suppliers has their own preferences, has their own vision of the future, how they would like to shape it. So, some of the diagrams I showed before certainly look very simplistic to a reality of the industries that we're trying to cover. But I think I agree with Roy that, apart from maybe optical transport, on many other situations, many other parts of the market, I think the glass is half full rather than half empty. So if you look back over the decade, we do see changes, and we do see the industry is changing. It's changing maybe in different ways that we expected, but it's certainly transforming itself. Change in Cisco strategy is a very good illustration of something that we haven't expected. And there are probably going to be more examples like that. So with that, I'm looking at the clock. We're at exactly 45 minutes, which concludes our recorded portion of the presentation, unless Roy and Stefan have any last minute comments or questions for me. We're going to stop here, and Roy and I will be available for live questions for the audience. I do want to put in our list of publications for the optical part of the company. So we provide at least one report every month covering the supply chain for the optical communications industry. And Stefan and his team at Light Counting does the same number of reports for covering the wireless infrastructure market. And just one last comment is, while I have the opportunity, I would like to thank the whole team of Light Counting analysts working around the world, supporting our research, interviewing service providers, cloud companies, and all their suppliers. Thank you, and we'll take your questions next.